We're Group 1 and we have hexokinase. Hexokinase performs step 1 of glycolysis in most tissues, including muscle and the brain.
Hexokinase enhances the nucleophilic attack of the C6-hydroxyl group of glucose on the gamma phosphate of ATP, forming glucose 6-phosphate. ATP binds to the enzyme as a complex with a magnesium ion. At physiological conditions, this reaction is thermodynamically unfavorable, so it is coupled to the hydrolysis of ATP to ADP and PI to make it a favorable reaction.
Once glucose enters a cell, it must be phosphorylated. This helps the cell maintain a diffusion gradient into the cell at high blood glucose concentrations and prevents the diffusion out of the cell at low blood glucose concentrations.
Hexokinase has a low Km, therefore a high affinity for glucose, permitting the initiation of glycolysis even when blood glucose levels are relatively low.
Hexokinase's Vmax is also relatively low.
Insulin enhances glycolysis by increasing glucose uptake. In addition, insulin stimulates the activity of the muscle enzyme hexokinase, which phosphorylates glucose, trapping it within the cell. Contrastingly, hexokinase is inhibited by glucagon, glucose 6-phosphate, and acetyl-CoA.
Hexokinase deficiency is a disease known as nonspherocytic hemolytic anemia. It is inherited in an autosomal recessive manner, meaning both parents must be carriers of the recessive gene. When two carriers of the same autosomal recessive condition have children, each child has a 25% risk to be affected. The offspring of two carriers can either have both recessive genes, giving them the disease, or can be unaffected by both having a recessive and a dominant gene, or both dominant genes. Signs of this deficiency include jaundice, lethargy, and pale skin.